So for this next one, we see that we are adding something to the x prior to taking the sine of it. So what this does is move your graph to the left or to the right. So when we're adding, it's going to move it to the left. If we were to subtract, it would move it to the right. We call this a phase shift when we're moving to the left or to the right. We're taking our graph and shifting it over. Okay, so really what's happening here is that my x is changing. So all of my y values are going to stay the same. I still have 0, 1, 0, -1, and 0. But I am going to move it to the left pi over 2. So if I take 0 and I move it to the left pi over 2 spaces, I'm at negative pi over 2. If I take pi over 2 and move it to the left pi over 2, I'm at 0. Again, pi over 2 would put me here at pi over 2. So I've moved everything to the left pi over 2 spaces. Really what we've done is taken that x and we have subtracted pi over 2 from the original x values. So kind of the backwards. Anytime we're on the inside of what's happening, like what we're putting on the inside of sine, we're going to do things kind of backwards from what makes sense. All right, same concept, but this time we're subtracting. So we still have 0, 1, 0, -1, 0. But this time what we're doing is moving to the right pi over 4 spaces. So let's just tick off those over 4s. Right, this would be pi over 4. This would be 3 pi over 4. So we're moving to the right pi over 4. So this point that I have here at 0 is going to move to the right pi over 4 spaces. The pi over 2 is going to move over pi over 4, pi over 4, pi over 4, and pi over 4. So everything's just shifted over to the side, pi over 4 spaces. So again, it's like adding this time because it's backwards, pi over 4. So I get pi over 4, I get 3 pi over 4, I get 5 pi over 4, I get 7 pi over 4, and 9 pi over 4. So really this is like adding pi over 4, and before it was like subtracting pi over 2. Okay. This, very much so like quadratics or cubics or any of them, when I just add a number on the outside, which often we'll write it in the front, though you could write it at the end. That way it doesn't look like it's part of the x. When we add or subtract that number, that's just going to move us up or down. So in this case, this 2 just means we're going to move up 2. That means my vertical is going to change. So all of the beginning x values are staying the same. I'm still taking the sine of the same angles. But I want to move everything up 2 spaces. So this point here at 0, 0 is now going to be up at 0, 2. This point here at pi over 2, 1 is now at pi over 2, 3. I'm moving everything up 2 spaces. Okay, everything has been moved up 2 spaces. So all that's really happening is that I'm adding 2 to the y value. 2, 3, 2, 1, 2. Here we're moving down 2. Don't let this negative fool you. That's your down. That is not telling us reflect because the sign is still positive. Okay, S-I-N is still positive. So again, I'm just moving everything down 2. So that point here will move down 2. The next point will move down 2, down 2, down 2, and down 2. I'm just moving down 2 spaces. That's all that's happening. I've just picked this up and pushed it down. So again, same concept. The sign of the angle is not changing, but we're just changing what happens to the y's. So down 2 would subtract 2. So that'll give us -2, -1, -2, -3, -2, and so on. We could keep going. All right. Lastly, we want to look at the graph and be able to come up with the equation given the information from the graph. So there's a few things I want to look at. I want to think about what is the amplitude? What is the period? Have I shifted anything to the left, to the right? Is anything changing here? So when I look at this, the first thing I should notice is kind of where's the middle of my graph. So we call this the midline. So the midline would be halfway between the highest and the lowest point, and that would be right here. So that is my midline. So my midline is at 0. That tells me I don't have a d. I'm not adding or subtracting anything to this equation on the outside. I do notice, though, that I have my amplitude. My amplitude is from the midline all the way up. So my amplitude here is actually 3 spaces. And since I am going up first, then I know it's positive 3 instead of going down first. All right, so far I know that I have y is equal to 3 sine of x. I know I'm not adding anything to this in terms of d for the outside. What I do also want to note is, do I have a change in my period? What is my period? So I have to have all 5 of those points happen to complete the period. And it looks like I'm going from 0 to 2 pi. So 0 to 2 pi, that means my period is 2 pi, which is the normal period for sine. So nothing is changing there. And since I am starting at 0, 0, I know I am not shifting at all. So y equals 3 sine x. That's it. Let's take a look at a little bit more complicated. So let's look at part B. My midline is no longer at 0. I see that I'm here at these 2 points. Halfway between would be my midline. So my midline is actually at 1. Okay. So what that means is that I have moved up 1 space. Everything is up 1 from the middle. Okay. So I know that at some point I'm going to be adding 1. You could do it in front or you could do it at the end. It's really up to you. I'm going to do it in the front. I notice that from my midline, I am going up first, so it's going to be a positive sign. But I do notice that it's an amplitude of 2. So A is going to equal 2 here. So 2 sine. And then I want to know, is anything changing? Well, my period is from 0 to 2 pi. So my period is the same, and since I'm starting at 0, then there is no phase shift. So I have x plus 2 times sine x, or sorry, 1 plus 2 times sine x, or I could say 2 times sine x and then plus 1 at the end. We just don't want to confuse that 1 as being inside. Okay, the next one, we see that our midline, if we go from the highest to the lowest point, our midline is 0, which is nice. There is no up or down movement here. I do see I have an amplitude of 3. So A equals 3. So we have y is equal to, we definitely are going up first. So it's a positive 3 sine. And then of what? Well, my period is changing. I see my 1, 2, 3, 4, 5 points occur from 0 to pi. So that means it's half as big. So if my period comes from 2 pi over b and the answer is equal to pi, I could cross multiply, or I could probably reason this out that b had to have been 2. So I'm going to have 2x on the inside there. So I'm taking sine of 2x. And that's going to count for my period. But I'm starting at 0, so I don't have a shift. All right, and lastly, I have actually a few different answers I could use here. The easiest one, I notice that my midline is 0. So my mid is 0. I notice that my amplitude is just 1. But I do notice I go down first. So I have negative. So that's y equals negative 1 sine. And I'm going from 0 to 2 pi. And I'm starting at 0, so there's no change. So this is just negative sine of x. Though I could have thought of this another way. I could have thought of this as being a phase shift. I could have thought of really saying that I took, if this was my, if this was the start of my graph, maybe this orange part, I could have said that really I've taken my original and shifted it to the right, a whole pi. So that would be another option too, and saying that it was a normal sine, I just moved it to the right pi spaces. So I could say that y is equal to sine of x to the right would be minus